your new point, the one that the new household, and you have to z-score that one. What's nice about doing it in Excel is that if you did in Excel, as soon as I started typing my new point in, it did this. I didn't have to scroll anything down. It automatically gave you the new Z1 and Z2 score. I'll show you what I mean by that. Like if I erase this, if I go in here and erase this, those things disappear. But if I put 90 and 6 back up here, it gave me the new z-scores. Pretty nice. So I'm good with that. I like that. Notice I put a question mark here. The mistake that students made last year is they would put stuff here. It's the one they would include this data in their training data set. This is the new data that you want to predict. None of it should be, you shouldn't compute your mean with these two in here. So they would compute the mean with these two in here. Don't do that. You're better than them. You are, right? I'll tell them you said that. Julie, you didn't have to tell me this time. I made a verb out of it. Z-score the new data point. So then you're going to have for x1, let me call it Z. I can't read my own writing.
So this new data point is the data point that you're trying to predict?
Yes. So you need to have everything in the same planet. So that's why you z-score it. But this mean here is the mean from training data. Not with the new point in it. And this is the standard deviation from training data. So you put that in the beginning. And this is being recorded. So if any of the yucks are really like wanting to see our class and they happen to be your team leader, they'll hear that you said that you thought you're better than them. Let me know if you needed me to go back to that page. Got it? Big thing. See like how I put dark box? This part's your training data. This is what you find the mean and standard deviation for. Don't include these two in that training data. The new data point you're trying to predict. If none of you do that, you are better than them because they did that last year. Okay, so next step, step 4. All right, let me finish up. I forgot to do the Z. Can I just do this? Yada, yada, yada. The Z for X2 is same thing, same algorithm. You get negative 0.2341. So I have a new Z. Okay, same thing. And then next step, this is the last one. Oh, second to last one. Remember the distance formula? The new point was 0.47432 and negative 0.23415. That's, you have an x and a y because there's two coordinates. The x1 would be your first coordinate and your x2 would be, so these are the z-scores of the two. You're going to take that point and find the distance between every single one of these other, these two, and I'm not going to do that by hand. So I'm going to show you one by hand of what it looks like. So D would be the square root of the first, I'm going to call it Z1 because it came from the first column, minus Z1 new squared, just so you know what I'm talking about, and then Z2 minus Z2 new squared. Remember that formula from high school? Grade school? Where do you learn this now? They're pushing it earlier and earlier. Middle school. So yeah, I learned this in high school. You pop it in there. So for my first household, that's this thing right here. I go to these two. For the first household, it would look like this. It would look, D would be square root of, it's an ugly mess, and I was itching to not do this by hand, but I felt like I had to show you once, and I will never do it again. It's more digits than that. If you're doing these by hand, which I just detest doing these by hand, you have to watch your signs. I'm running out of space, but there's a squared up here. And I just crank that out on a calculator. You get 2.556061819, something long like that. I'm not doing that by hand. I just went in here and said, do it. So that's my formula. You're going to have to do this for your project. This is the formula for it. You take the SQRT square root, big parentheses, and take E2, which is the first z-score, minus the new point, which was 0.47. See that I did that? Squared. And then F2, which was that z-score. Well, in this case, it should have been minus the minus. Yeah, but that was negative. So it was negative. So I did the minus in my head. Minus the minus was plus. I'm teaching my nieces and nephews that right now. Minus the minus is plus. So I made a plus there. So it's not always a plus. We could have done minus and put the negative in parentheses. And then I just double clicked. I went like this, made a little cross like this, double clicked, and it spit me down the formula the same way all the way down. So, because I don't want to do that by hand. So that's how you do this part. Okay. Then, almost there. Don't lose me yet. Don't fall asleep. I know some of you already have. I know some of you figured out how to fall asleep with your eyes open. Question?
Yeah. What did you use the distances for in your lab?
So yes, so that's what we're missing right now. Really, it's like you're looking at this new point and asking, which of these other points is it closest to? And watch in a second, you'll see what I'm going to do. Last step. Step 5. I'm going to use k equals 3. They call it KNN, k nearest neighbors, the 3 nearest neighbors. For my point, the 3 nearest neighbors, the ones that have the closest distances are this guy, and this side. These 3. Those are the closest in distance to my new point. Closest. Let me write that better.
Man, we can't see.
Julia. So look at here, like these, I just computed all the distances of my new point to the existing points. These three were the closest. This one was the furthest. So KNN for k equals 3 would look at the three closest and look at the majority rule. So if I go over to there, the majority of these three were yeses. So my prediction is yes. Does that make sense?
So you would find the ones like closest to your new point that you just
Yes.
found. To like the distances.
Yes, it's like they voted. These are the distances in Z-score land, right? So Z-score everything, and then check the distances in Z-score land. And it turned out that these three were the closest in Z-score land. That's why you have to, if one variable is really large and one variable is really small in size, you can't compare them. So Z-score them first, so they're on the same planet, and then check which distances are the closest to your new point. And the closest are to this new point is these three.
How do you know that?
Because they're the smallest.
Or just the smallest number?
The smallest is away. And because they're the closest, I just look at it. One was no and two were yeses. The majority were yeses. So my prediction is my new guy is going to be probably a yes. And we try to do odd numbers for KNN. So you could do the same thing with 5. What about if I chose 5? So yes, I'm going to predict they will buy my product.
Oh, never mind. I forgot what the yes was.
Yeah, it was for buying it. I mean, it's a problem. It's not real. So let me ask you about 5. If I chose 5, what would my 5 nearest neighbors be? My top 5 nearest neighbors. Would it still be yes? I don't know if it will be. I didn't try it out.
Yeah.
If I pick the 5 nearest neighbors, say K equals 5 instead of yes. Well, what would I get? So who would I add?
7, each 7.
Household 7 would be included because it's 0.9. And the next one up would be this one. This 3. So that I got an additional no, but I got an additional yes. So it's still yes. Majority is still yes. It was 3 yeses and 2 nos. So it's a pretty simple-minded machine learning algorithm. It should make sense all the way through.